are solving ISS 2022 paper 1 and question number 15. So we have given x1 x2 following bivariate normal with the mean 0 0 and variance 1 1, and correlation is given to be x1 x2 is rho, and we need to find expected value of x1 square and x2 square. Okay, so there are two ways we can do this problem. The first way is that we can differentiate the homogeneity function with respect to t1 2 times and t2 2 times, and then by substituting the values of t1 t2 is equal to 0, so then we will getting expectation of x1 square and x2 square. So this is basically a long, we need to differentiate 4 times, and we know that the homogeneity function of the bivariate density is a complicated one. So we will do this question by the second way, by comparing the coefficients of t1 to the power r and t to the power s divided by r factorial and s factorial. So let's do this. Okay, now so we have given that x1 comma x2 is following bivariate normal with mean 0 0, variance 1 1, correlation coefficient is given to be rho. Now write the movement generating function first. So movement generating function, we know that e given by it, but mu1 t1, mu1 is 0, mu2 t2, mu2 is also 0, so that term will be, so let me write. So if in case if anyone do not know the movement generating function of movement generating bivariate normal distribution, then it will be revised for those candidates to rho t1 t2 and sigma 1 sigma 2. Now we have given v1 v2 is equal to, so this term will become whole 0. Now sigma 1 sigma 2 is 1, so this will become half t1 square plus half t2 square. Now 2 2 will get multiplied and cut it out, and this will become half t1 t2, because we have sigma 1 sigma 2 equal to 1. Now expand this, and if we compare the coefficient of t1 square and t2 square divided by 2 factorial, then we will be getting expectation of x1 square and expectation of x2 square. Okay, so let's expand this. So these are basically in multiplication. So first expand this. So the expression of this will be 1 plus half t1 square. We do not need t1 to the power 4, because okay, we need to consider only this term. Similarly, if we expand this, this will become 1 plus half t2 square. We do not need higher term. Similarly, expand this, okay, e to the power of t1 t2, this will become half rho 1 t1 t2. Now we will need next term, because this will contain t1 square t2 square divided by 2 factorial. Now 2 factorial is basically 2. Now we do not need in this expansion long term, because t1 cube and t2 cube we do not need. Now what will be the coefficient of t1 square, and so we can write it as t1 square t2 square divided by 4, because those are 4 होता है. And now the coefficient of t1 square t2 square will be, so first way, so if you multiply this and this, so we will getting 1 by 4 t1 square t2 square, and if you multiply this one and this, so you are also getting rho square t1 square t2 square divided by 2. So this is the two possible ways. The first way is this multiplied by this and with this one, and the second is 1 1 and this, so we will getting this. Now we need to find coefficient of this, so common this, so common t1 square t2 square divided by 4, here will be 1 and here will be 2 rho square. So the coefficient of t1 square and t2 square divided by 4 is this, so this is giving me the value of expectation of x2 square. So